Okay, so we can get started on this first session of day 2. Thank you for joining us again. For this session, we have the pleasure of welcoming Uli Sauerland and Gary Lupyan, both of whom are working on the relationship between language and thought. And some of the questions guiding this research pertain to the function of language in communication and thought. So is the function of language to better communicate our thoughts, or does language actually shape the format and the structure of our thoughts? In his work, Gary has put forward the idea that language augments our thoughts, while Uli's perspective has been that language compresses thought. So hopefully today we'll see where these two notions of augmentation and compression come together. And first, I'll hand things off to Uli Sauerland, who is Vice Director for the Leadnet Center for General Linguistics in Berlin.
Okay, thank you, Rachel, and thanks everybody for coming. And we'll start my screen share. Is that okay? Everybody? Yeah. Okay, so I'm presenting a view of grammar that kind of is the reverse of the usual relationship one sees between meaning and grammar. So usually one talks of assigning a meaning to a sentence, but I'm presenting a view where you assign a sentence to a meaning rather, and I give you some arguments for that. So the starting point of for my talk today is a question of how do we generate complex thoughts. And one view that is very prevalent amongst linguists, but most clearly articulated by Liz Spelke in a 2003 paper, is that language is crucial to generate complex thought, and in particular, the compositional semantics. So my view of the quote is somewhat blocked. So she says, thanks to their compositional semantics, natural languages can expand the child's conceptual repertoire to include not just the pre-existing core knowledge concept, but also any new well-formed combinations of those concepts. And so her perspective is that from developmental psychology, and she sees a big jump between the pre-linguistic child and the linguistic child. And I mean, this view is popular amongst linguists in particular because it's very well fits together with a view of grammar, where grammar is taken to be the kind of a central mechanism of building structures. So in the so-called T model of grammar, the view is that there's the central component is a generator that has an operation merge or something similar that takes simple elements and builds complex structures out of these with a recursive operation. And then these representations are kind of interpreted so mapped onto a thought, but also mapped onto an articulation. That is the kind of model of grammar. And I sort of throughout will give you some reasons to, that cast at least a bit of doubt on this model and make it, I think, motivate to at least investigate an alternative to this model. And I'll start off with one argument that relates to a prediction of this model that it makes for animals. So Spelke was primarily thinking about pre-linguistic children, but also animals that don't have language are predicted to lack complex concepts or complex thoughts if sort of only the compositional semantics of language allows you to form more complex thoughts. And and here's an example of an animal, the crow Betty, kind of older example, but in a research lab in Oxford, and this is not a trained animal, so what you see is kind of spontaneous behavior of the crow in this environment. And she has and there's in this clear tube there's a bucket, and inside of this little bucket, the bottom of the tube, there's some food item that the crow is trying to get to, and the crow has a metal rod in its now it has an idea, after sort of trying for a while unsuccessfully, how to get to the food. And you see that it very purposefully bends the rod, inserts it back into the tube, and now pulls up the bucket, and tada, bravo, managed to get the food. And you see that this is sort of purposeful behavior, and it seems to rely on a conditional thought that if the rod was bent, I could get the food, or I could pull up the bucket or something, and that would be a complex thought. So that at least this, I mean, well, I didn't mean to show you this again. Okay, so that at least motivates to explore a bit alternatives to the standard T model view. And and then the alternative would be, well, these complex thoughts are generated independent of language. So the operation of merge is not in the grammar, but it's somehow in the conceptual system. And that creates first complex thoughts, and then humans furthermore have the ability to communicate these complex thoughts. And the question is, well, how do they do that? And one sort of, in previous explorations of some ideas similar to this, was then assumed that, well, basically there is sort of a direct mapping of thought to an articulation, so that they sort of, each concept stands in a one-to-one relationship to a morpheme of the language, and this is also in generally assumed in work in formal semantics. But from this perspective, this doesn't seem so natural, because if I mean, this articulation process is something sort of on top of this, and it's more like when you sort of have a file on your computer, and for the internal processing of the computer, it might have a very rich structure to facilitate internal processing, but a lot of that structure might actually be redundant, and to transmit the file, you want to compress it to sort of make it easy to be sent around, and assume that something similar holds for human communication, so that languages compress thought as much as possible, and thinks that there's another motivation for this is just that it's been found to be very hard to kind of come up with a reasonable one-to-one mapping between morphemes and concepts in general. So we assume that there's a compressor and then the articulation. Now that sort of gives rise to these cartoonish possibilities like this, that you have some kind of very complex structure that just with lots of kind of component pieces, that is the kind of data structure that would be a thought, and this funnel is a compressor, and out comes a single word like no or something, and you see that this sort of opens a new realm of possibilities here, this view. Sort of in realistic cases, I mean, we want to understand this better, but I mean, yeah, here's one example where this kind of, you see how sort of this is in a more garden variety case would maybe apply this obligation to compress as much as possible. So if we have something like a structure that has a meaning roughly of V at the present time, like linguistics, this could be, and then there would have to be some sort of relationships between morphemes and between basic concepts, primitive concepts, and morphemes. And for example, the present tense might be related to the unarticulated morpheme, null morpheme, or it might be, or it might also be relatable to the morpheme do. And here, I mean, marks that this null articulation would be maybe restricted to a specific environment in English, namely when it's in front of a verb. This should be dots, so the in front of a verb. And then this would predict that, well, two possible sentences that, or articulations that could be assigned to this sort would be we like linguistics or we do like linguistics. But this requirement to compress as much as possible would block two and only allow one. And that's sort of the more frequent, at least, expression in English. Now, to account for the fact that also sometimes two is possible, and so we do like linguistics, that would have to be derived, would have to be an articulation of a different sort structure then. So for example, one where there is focus applying to the present tense, like here, where then this environment condition of the null articulation would be blocked, and therefore only two is a possible articulation of T prime. So that's kind of the basic framework we are assuming. Another, but you see that, I mean, in most of these cases, the problem is we don't have any understanding of what the content of these sort structures is. In this cartoonish example, it was something of great complexity, and that came out as a single word. And we need to somehow understand from the articulate, like how articulated forms can relate to these sort structures to spell out more about this model. And so we need to overcome this compression process in various ways. And I'm going to, in the following, talk about 4 different ways of doing this in different levels of detail. So I'll first talk about something that's kind of close to my heart, and it's so the most technical of these, but it's the one that sort of was also the original motivation for pursuing this avenue. So that is called the sort uniqueness condition, and then there are sort of ways of looking at either typology, so that's into so if the assumption that different languages have different ways of compressing, and so you can see different parts of a sort structure in different languages. And assume that often a lot of the sort structure really you don't perceive in the language output. But maybe in one language you perceive slightly different elements than in another. And this some way supported also by the idea that there's parallel compression in cases where you when people have multiple languages, use multiple languages simultaneously. There's maybe more. And finally, the one that is sort of currently has the biggest hope of like yielding main result is the idea that in children sometimes the compression is not quite as strict as in adults, and therefore you hear some extra elements of thought structure in child languages. I'll show some examples of that. Okay, so so let's start with logicality. So this is in observation that since the last close to 20 years, been increasingly been picked upon in English that subtle logical properties really relate in a very direct way to grammar, and the sort of logicality is the assumption that, or what I call here logicality, that analytic sentences are just ungrammatical. So sentences that are either always true or always false, or contradictions or tautologies are just, you can't pronounce them, or they're rejected by the system. And then this is sort of a notion of tautology that ignores sort of effects of the sort of lexical meaning of content words, but is only sensitive to logical structure in a sense. But an example of what this is argued to exclude is something like a student but Laura arrived early, which is bad, ill-formed in English and perceived to be bad. Okay, so and this is, I mean, you have to just if you are not with this, you have to read, for example, Gennaro Chiacchia's book exploring this idea. This team book. Now, here this is kind of still possible to look at this in the way of, well, you map a sentence to the meaning 1 or 0, and then you kind of mark that as ungrammatical. If you have a sentence and determine the truth conditions of the sentence. But in thought uniqueness is a sort of an extension of this idea that compares two possible structures and says if the two have the same truth conditions, only the more efficient one, the simpler one, can actually be formed. And I mean, this kind of encompasses logicality as a special case. If you think that, I mean, any tautology, you could either say that you have sort of the 1 or 0 as a representation, in any more complex sentence, like such as here, a student but Laura arrived early, that's then blocked. So this is a more general condition. That sense, but it has a different character in that you have to compare two structures that have the same truth conditions, and then some of the less efficient one you ultimately are sort of rejecting. So it's more natural to look at this from starting with the truth conditions. So you kind of have truth conditions that are sort of your target truth conditions, and then you create the simplest structure that has these truth conditions. Now this, I give you an example of this. I try. So this, first we see an example where two different structures are possible here, or like from the same words and with quite similar meanings, but a subtle difference there. And these are in 1 and 2. So which girl invited which boy versus which boy did which girl invite. People who have thought about meaning of questions in English have observed that there is a subtle difference in the meaning between these two. Namely, the first one sort of tells you each girl invited exactly one boy, or it presupposes that. The second one, though, tells you for each boy exactly one girl invited him. And this kind of slightly fuzzy, unfortunately, the tables in A and B illustrate in A a scenario where like these three girls, Anne, Bia, and Cell, each invited one boy, but not each boy was invited by one girl. So that would be a sentence, a situation where a sentence question one would be a good question to ask, but question two would not work. And B is a kind of reverse scenario. Now, this subtle meaning difference in this case depends on the number marking that you have here on which girl and which boy. That gives you rise to this condition that there has to be for each boy one girl, exactly one girl that, or vice versa, depending on how this applies. Now in English, though, you also have question words, question pronouns that don't have number marking, and namely, well, who and what. So let's look at who. And this is well known that in the linguistic literature, that when you have who in both of these positions, you can't form the two structures. You can only form one of them, namely who invited whom. And whom did who invite is not at least perfect. So people, English speakers, somehow have a problem with that. And this now follows, in this case, from it follows from this thought uniqueness condition, because this subtle meaning difference that was dependent on number, once you are looking at question words that don't have number marking on them, it disappears. And the two, one and two, I mean, two is, you can't interpret two because you can't even form it, but they would have the same truth conditions if you could articulate the two structures that here give rise to one and two. And you have to somehow assume that, well, one is in this abstract way more efficient. And that's why only one can be actually formed by your mind. And then there's no other kind of structure and that could be articulated as two. So earlier we saw something with, maybe there's another structure where you have the focus in there. In the we like linguistics examples, but maybe in this case there isn't, or it doesn't come to your mind so readily, another structure. So then two ends up being just like a sentence that cannot be, that there can't be any thought that gives rise to that, because that representation is impossible. I don't know. Try to put an analogy here. So this is kind of like, I mean, the first example, the one with which, is kind of, I mean, this is kind of taking you back to high school algebra, and you're supposed to simplify examples, and then your teacher will be happy if you have 2x equals y or x equals 2y. Those are both as simple as can be. If you look at x equals y versus 2x equals 2y, your teacher would like mark this 2x equals 2y as not being as good, because as being not simplified, because x equals y is kind of satisfies this condition of being simpler, and and this is because, I mean, here again, or in this example too, well, these two are equivalent on the right-hand side, and then x equals y is somehow perceived to be simpler or more efficient or something. So this, yeah, gives you some idea of sort of how to work with this. I mean, first of all, how the sort uniqueness condition would enter these considerations and motivate also a view where you really start with the truth conditions of a sentence and then form the simplest, only the simplest structure for capturing those. But also because you need to, I mean, if you have alternative ways, we don't know what the atoms of the primitives of thought structures are at this point. If you are comparing two ways of forming thought structures for here 1 and 2 on this slide, you would want one where it somehow comes out as natural that the thought structure of 1 is more efficient than that of 2. So ideally one where the thought structure of 1 just has fewer elements in it than that of 2. Okay, and that might give you some way of distinguishing between different logical possibilities. So logical in a double sense of, yeah. Okay, so that was the most complex type of possible argument of approaching here this problem of overcoming compression, and the others I think are a bit easier. So the second one that I listed at the near the beginning was that if you look at different languages, they might articulate different pieces of a thought structure. And so comparing languages, we might be able to figure out thereby what pieces are present in a thought structure. If you look at, in particular, of sentences that seem to express the same thought structure, so have the same meaning in some way. And one potential example involves kind of coordination of non-Boolean elements. Like, so you can form the phrase Mary and Bill, but typically people think that and is something that connects to truth values or to things that have truth values, and Mary and Bill aren't truth values or don't have truth values. Fisher, so you and people have suggested that you need to argue that you need to somehow apply some operation there that I here indicate when you apply something like and to Mary and Bill, something like this subset operation to form something like, oh, the set that has Mary as or the set of Mary as a subset and the set of Bill as a subset, and that gives you the set of Mary and Bill then by some further operation, but it's a bit abbreviated here. But assume that there's something extra in the structure when you have Mary and Bill. And in English, so you would only pronounce in the structure the logical coordination and so you hear Mary and Bill are happy. Articulate that. But in another language, you might instead articulate this subset operator and then maybe not the and, because then that would be kind of redundant. Then you would know that, well, the reason that this is here, you might be that you want to apply the and the possibly here Japanese might be such a language, because in Japanese you have a element mo. I mean, one possible way of forming at least coordination in Japanese is by applying mo to Rose, Mary, and Bill. Yeah, and then the sort of other occurrences of more, other uses of more in the language suggest also that it has not the meaning of a logical connective and, but rather something more like maybe a subset operation. So it also can express universal quantification, for instance. So that would be a way of arguing that in this Mary and Bill kind of structure, the underlying sort of thought representation would have an additional operation as part of it. I don't know, maybe. I mean, this is. I mean, just very briefly, a kind of different version of this would be, or in some sense, a prediction of this would be that, I mean, if people articulate the same thought in different languages simultaneously, in particular, so this, and the most dramatic case would be kind of multimodal articulation. Prediction would be that, well, I mean, speakers could have, I mean, assuming that they have just one, can only form one thought at a time, or at least the normal people, then you would expect it, but maybe they can, if they do simultaneous articulation, they have two of these kind of compressors working in parallel. And the prediction would be that you can do this as long as it has the same, articulates the same thought, and it could come out in the different ways in the different languages that they're using simultaneously. And possible evidence for this is in work by Banchini and Donati, where they propose that in it, I mean, they observed examples where speakers, bimodal speakers simultaneously produce in Italian something like, I don't understand, io non ho capito, is a negation in front of the verb, but in Italian Sign Language, the reverse word order, which each of these word orders is the appropriate word order for the language. So this kind of would fit into the model if this is restricted to cases where they start with a single thought, but then they have kind of different ways of mapping this to different articulatory systems that they control in parallel. Okay, so the last example I wanted to talk about, a last class of example of a possible source of evidence, is the phenomenon that a child language sometimes seems to be over creative. That the children, even though generally children produce shorter utterances and leave out words where adults produce them, sometimes they produce extra words in places where adults don't seem to be producing words. And a classical example of this is in English intermediate, so-called intermediate WH, or who do you think who is in the box? Another example from work of Kazuhira Tsushiro and mine, but also found in other languages, is that in relative clauses, at least, sometimes the relative clause internal position is filled with a definite description. So something like, I want to be the girl who the granddad hugs the girl, which is ungrammatical in adult German, but found in children. And yeah, other examples from work by Quasti and others involve sort of multiple articulation of an auxiliary. And I mean, I'm not so interested in the, I'm not going to say anything in detail about those cases, but the kind of simplest example that I think of is something that I observed with my own children when they were younger in German. So and involves the preposition for ohne in German. So translated into English as without. But crucially, I mean, in English, without kind of contains the with as a part, so it's bimorphemic. German ohne is monomorphemic, but I think all German children do, and they definitely mine did. And this is not one of my own children, but it's that of a colleague of mine. And you probably won't hear this, but so the child says what is written here. Der Zug ist mit ohne Anhänger. I don't know whether you heard it now, but otherwise I won't be able to fix it anyway. And so it kind of seems to produce what corresponds to the English without. So, but for adults, this is not the way they would say it. You hear it again? No, that was not my intent. Well, and here's a kind of data collection effort on the basis of the childish corpora from German children. And in purple, and this is sort of shows all occurrences of this word ohne in German children. And the ones where mit precedes it, so the word for with, are marked in purple. So you see that that's very frequent around the third year of third birthday, but then basically disappears in children. And yeah, and we also I mean, this is more at this point still anecdotal evidence. We asked people across the world, experts on child language, whether they observe something similar in particularly in languages where with is not where without is not bimorphemic as it is in English, but like in German is monomorphemic. And the report were this is not very organized, but that this something similar to the German phenomenon is found across a number of languages. So not just Indo-European languages, but a few others as well. And this kind of is something to we're currently investigating further. Okay, so this then suggests that that somehow without explanation I suggest here is that without cannot be a primitive concept for reasons that, I mean, maybe just you whenever you could get a concept as a negation of another concept, you have to sort of break out the negation, or something more, some more complex cognitive conditions, and then the assumption then and then so it would follow that while there has to be when German children realize that ohne is has a meaning without, they have to sort of say, conclude that the underlying the thought structure must be something like with and a negation, as also in English. But in English, both pieces here are articulated. So we have with and out somehow seems to express a negation. But in adult German, only the negation piece is pronounced as ohne. And children seem to conclude, well, I mean, since there is this way of articulating also the with piece, that is at least, I mean, at least some number of cases they do use that morpheme as well and articulate mit ohne rather than just the adult form. Okay, I think, yeah. So that was, yeah, I mean, this last approach is kind of the one sort of that can be most easily applied to further phenomena. So it involves looking at cases where children produce extra word, and preferably ones where you find this sort of in some systematic fashion across multiple languages. And this you can sort of take as evidence for the presence of unarticulated material that's present in the thought representation. And yeah, so, and hopefully deduce some general principles of these thought representations, like this type of condition that negation cannot be part of a primitive concept in some sense. Yeah, so to conclude, I mean, so I've sort of given you a sketch of a novel theory of language where we start with meaning, and that is then mapped to a sentence. So, and yeah, this is a sort of marketing verbiage, or so that languages are, especially the child language, are window of the human mind, and the central challenge here is overcoming compression. So it's, and then child language is the best way of doing that. And on this approach, I mean, that's maybe also relevant for the general theme here, is that these, at least the purely logical meanings, which, I mean, the assumption was also that we share to some extent with a crow, would have a purely cognitive foundation, and this includes logical aspects of kind of the content words, like being an object or being an event description. Yeah. Okay. Thank you.
Great. Thank you, Uli. So now take a second to thank Uli, and we'll also open up the floor for questions on Uli's talk. So if you have one, go ahead and register yourself. We'll take the first question from Magdalena. We can't hear you yet. You have to unmute yourself.
Now?
Yes.
Yes, Martha.
Okay. Hi. So I was wondering,
Hi.
so I would like to understand your model a little bit better. And so how does the model fit together with the observation that of redundancy in natural languages? I mean, the compressor should compress or everything should be as simple as possible, if I understood you correctly. So do you predict then that languages develop towards simple solutions, or yeah, what do you think about redundancy?
Well, I mean, the compression has to be modulated by kind of the desire to be understood or to transmit some content, and so, I mean, some redundancy may be included to kind of make sure that even in the case of transmission errors or something like that, you would have to, the meaning would still be transmitted successfully, or with a reasonable chance of success. Of course, we know that there can be misunderstandings, but that general, you know, that So then that, I mean, this is, I mean, it's supposed to be also a bit of a kind of a situational calculus, like in legal documents where much more is at issue. You don't use pronouns maybe as much because they create some ambiguity, and you produce definite descriptions. So I mean, there have to be also, yeah, I mean, so sort of the cutoff between, well, when it becomes completely ungrammatical to produce extra material in these cases is to be determined.
Okay, so you think there are different types of constraints that might delimit the set of possible compressors, because as if I understood you correctly, the compressors might be language specific, right?
Yeah, so this English example, or the case of without, is supposed to illustrate that a little bit, like that in the German ohne really only occurs with this without meaning, whereas the English out has uses other than that. I'm going out or something. I'm not allowed to go out, rather, but yeah. And so that seems to be playing a role in the fact that in English you do pronounce it with it's let's see, but I mean it has to be also to some extent kind of conventionalized in a language, that how you compress specifically. Yeah. So
okay.
I mean,
Thanks.
there are some kind of general properties of this, but yeah. Okay.
Okay, we'll take our next question from Andrew.
Hey, thanks for the talk. So I'm just trying to get a grip on your idea from the beginning, when you were kind of pushing back on the Spelke idea that it's language that's going to allow you to compose these complex thoughts. And it seems to me that all the data that you were giving here is consistent with the idea that Spelke's correct. It's just that there's underlying linguistic structures that eventually get compressed on the way to articulation. So you could have some sort of underlying logical form, say, that is what allows children to combine thoughts. And then sometimes the young kids pronounce stuff that usually gets compressed in adult speech. And, you know, generally we form these different logical structures, but then some part of the language program prunes away these unsimplified forms. But it seems like Spelke could still be right that it's in the end language which is allowing this composition. So I was just wondering what you had to say about that.
Yeah, thank you. I mean, you're right now that not all of my cases. I mean, one could pursue a perspective sort of that's has much of the structure formation happening in the for many of these cases. I mean, it's I mean, it doesn't do the crow, I assume, but I mean, in the
I'm sympathetic
yeah,
to
I mean, it's
your
a sort
view.
of
I'm just trying to.
yeah.
I went to see what the language specific evidence is, because that would be useful.
Yeah, so I mean, I sort of contrasted it. I mean, what you're advocating is not. I mean, it's maybe Spelke, but it's not like the T model architecture of grammar, and that was more what I was had in mind. That and there, I mean, for example, in this case with the two two different questions, ways of forming a question, where one of them is ruled out. I mean, because they do give rise to different strings, different sentences. It's kind of, I mean, that's kind of hard there to formulate on the T-model architectures, and on sort of my view, where you start with the meaning and say, well, because there you have to say, well, you form these sentences, and then you could in principle articulate them, and you can also interpret them, but still something blocks you at that point, and it seems unnatural to sort of build it all up and have all the systems ready to interpret it and pronounce it, but then say, oh no, we don't, there's a simpler way of doing it, so go back and do that. But yeah, I mean, yeah, these arguments are sort of very subtle, and I agree that once you sort of don't take any like a concrete spelled out models, you might be able to also formulate it more in a view where language plays a bigger role. Thank you. Yeah.
Sorry, we have two more questions we'll try to squeeze in. The first is from Val.
Okay, I'll be faster.
Hi, yeah, thank you for the talk. I was wondering what your ideas about the reverse of what you've been proposing, namely that I recognize and see the point in the Spelke core cognition combinatorics, but very often what happens, as Dan Sperber and Dad Wilson pointed out, this asymmetry between the public and the mental lexicon. So there are so many more possible thoughts, even of conceptual primitives, perhaps, I mean, simple objects, which are just need expansion, not compression. So for example, the plastic object you put your computer on while you're typing on your table. Now I don't want to reduce this to these lexical ideas, but I wonder what you think about the often experience. Of course, we need to compress, but then we have to expand a lot. How do these two things relate in your view?
Yeah, I mean, in some ways that's quite compatible, I think, because I mean, imagine that really what we do when we talk is we compress 100 primitives into one word. And so really the thought structures would be so complex, it would be completely impossible and unrealistic to use them and articulate them use them for communication. And ultimately it would always be something would be not fully specified in our articulations. So we would always be a bit frustrated, and so that would be, I don't see an incompatibility there. Yeah, say something else, but I forgot. But yeah, so yeah.
Okay,
I'll leave it at that. I'm sorry.
Maybe we can take our last question from Jennifer then, and while Jennifer's asking, I'll ask Gary to start his screen share. Thank you.
Hi, thanks very much. Yeah, I really enjoyed your talk. It's very interesting to think about. I was wondering, so there's a kind of large body of research now that suggests that efficient language is the sort of result of combined pressures from learning on the one hand and communication on the other hand. And so if you have only one of those pressures present, you don't necessarily get nice, efficient languages. And I was sort of wondering how, or if that connects with what you're thinking.
It does connect. I mean, I have sort of efficiency at various levels. So this is efficiency that the compression gives you, and that I think is quite close to these ideas that you are much more well versed with, I think. But and you're mentioning, I mean, there's other kind of efficiencies that applies at the thought structure level that is sort of has to be independent of communication, but it would also be present. Yeah, but I mean, but sort of the need to compress for transmitting, for communicating, is, I think, kind of the one that you have in mind, and that seems compatible. But yeah,
Okay, so for
didn't
now,
quite understand the role of acquisition in this, but yeah, maybe we can talk about it later.
yeah, for now, let's switch over to our second speaker and we can pick this up in the discussion period. So now it's my pleasure to introduce Gary Lupyan, who directs the Lupyan Lab at the University of Wisconsin-Madison.
Thank you so much. Thanks for having me. I was so inspired by yesterday's talks and posters. I ended up waking up even earlier than the kids and adding work that I wasn't going to discuss, but that connected with work presented yesterday. So if at any point you're thinking, geez, how many studies does he think he can get through? Too many probably, but at least you now know why. All right, so this is a sort of mixed crowd, although I probably don't need to define concepts as much as I do in some groups, but just so that we're on the same page, when I talk about concepts, I have the more psychological, more cognitive science notion of concept in mind rather than the philosophical one. It's a mental representation of a category, okay? There are all sorts of concepts. The kinds I'll be talking about are, you know, the everyday sorts of things. So yeah, animals, foods, right, artifacts. I'll also talk about colors a bit, and I'll touch on these formally defined categories like triangles, right? So where do concepts come from? If you're a voter, you reject the very question, right? For the rest of us, learning exists, and learning is a major part. Where do concepts come from? We learn them. And that, of course, raises a number of questions. The first being, what kind of experiences are central to learn? What kind of learning? What precisely are we learning? And the other question is, you know, what do we start with, right? What are the features that we might learn to combine when we learn a new concept, for example? It is a common move to posit, not just in developmental psychology, but in, for example, vision science, other branches of cognitive science. It's a common move to posit some set of primitives. And this, of course, just pushes the question farther, where do the primitives come from? And to this, the field is often a bit muted. So for example, and I realize that this is not the kind of concept learning many of you have in mind, but it is nevertheless a common way to study concept learning, learning of rule-based categories. So some categories are hard for people to learn, others are easy for people to learn. To the question of why, what makes something easy to learn, one answer is that the easy to learn ones are inherently simpler, right? Because they correspond to something like a simple rule, red things. What could be simpler? You have a primitive notion of redness, and if you have to learn or induce a category that includes red things, excludes non-red things, well, that's really easy. In comparison, trying to learn what Feldman calls a totally irreducible category, like a category containing a hat, a piano, the sun, and the king of Sweden, well, you know, that's pretty hard. right? And so its complexity is as high as it can be. The question I want to ask is, what is the role of language in structuring our conceptual repertoire? So do words, and I realize there's more to language than words. I'm not going to be talking about grammar. I'm not even going to talk about compositionality, which is obviously a critical feature of language. Just the vocabulary, just stick with that. So do the words we learn as part of learning the core vocabulary of a language help to structure our mind? Do they help us to induce categories, to form appropriate generalizations? So this is not a straw man sort of question, right? So why might someone think no? The answer is clearly not. One reason to think no, words don't do a whole lot, is to assume that words, while of course critical to communication, map onto pre-existing concepts. Now, those concepts might pre-exist because they are innate, or they're learned, but they're learned independently of language, right? So as Lila Gleitman, who is, I think, the most clear proponent and perhaps the most extreme proponent of this view, many others, I think, hold this view in a more implicit way. So Lila, right, the meanings to be communicated and their systematic mapping onto linguistic expressions arise independently of exposure to any language. And so if this is true, then language is a mirror of our conceptual knowledge, but not really a major shaper of it, right? And so notice that this view doesn't presuppose that the vocabularies of every language have to be the same, or that every concept we have corresponds to a name. So it's perfectly possible, to have some concept that in your language has no name, right? But the fact that you happen to speak a language that doesn't label blue, right, has no bearing on whether you have this concept. A reliance on this assumption leads, in some cases, to viewing language itself as a problem. So in a recent tweet, Jan LeCun, one of our most influential AI researchers, now head of AI research at Facebook, so he tweeted, language, right, is an imperfect, incomplete, low bandwidth serialization protocol for the internal data structures we call thoughts. Okay, not only does it not help, but it's annoying that we have to use it, right, to communicate. Why might someone think yes? So one reason is that the long understood, I think, idea that many of our categories or concepts are constructed. They're not just extracted from the world, they have to be constructed. And that part is, I think, relatively, at least within much of cognitive science, relatively uncontroversial. Where things get dicey is when we posit that linguistic experience forms an important part of this construction process. Right? Notice that this view, even a strong version of this view, does not presuppose that anything goes and everything is equally learnable and that there are no constraints on the categories you learn. The idea is simply that the categories we come to use are constructed. And the question is, well, how important is language to this process? Another reason to think that language might matter is, to use an excerpt from Steve Levinson's writing, is that language provides us with a lot of our cognitive chunks, right? Even in cases where there's formal equivalence. So 10 tens is the same as 100. But it at least intuitively seems like, isn't it handy to have just a word, a single word, 100, that's reusable, that's, can be learned as a single item? Or for something like aunt, right, that corresponds to a range of different relations, right? Instead of enumerating them, well, you just have aunt, right? Levinson further argues that composing complex concepts gives enormous power to our mental computations, but that we inherit them from language we happen to speak. Okay, so keeping this in mind, here is an alternative way of thinking about the relationship between words and concepts, right? That words don't just map on to concepts. Words and other cultural inputs help create them. So our semantic or conceptual knowledge derives from a combination of innate knowledge, core knowledge, clearly direct experiences, right? Perceptual experiences, motor experiences, but also language. Unfortunately, I don't have time to fully talk about, unpack the kind of learning from language. I'll focus on the empirical stuff instead. I look forward to engaging with Marina and her colleagues about the question of the role of inference and reasoning in this construction process. They tend to view this as being extremely important. I think it's something that we are all certainly capable of, but I think plays a relatively small role. So what is the evidence? Let me just begin to get at the evidence, the data. What is the evidence that categories don't just stare us in the face, that there's really a construction at work? One paper that I love and that I will only touch on for just a minute, because Asfa will discuss it at more length during her talk, is Asfa and colleagues' work on a domain in which you might expect much less variability than what you tend to find, that of language of perception. Why would you expect relatively little variability? Well, because unlike language about, for example, political institutions, you expect lots of differences there. How we see, how we smell, how we taste, well, we all have the same biology, right? So, and we inhabit, of course, different environments, but how different are they really? And so the assumption for a long time has been that you don't really find, if there are words for squares and triangles and reds and blues, it's because those categories are really out there. What you find instead is enormous variability, that the task here is to, given some smell, some taste, some textures, some sounds, shapes, colors, name them. And you find that on average, smells are harder to name than, for example, tastes. But in different languages, you have all sorts of rank order differences, right? So you have languages, many languages in which shapes are not readily nameable. There are no words for squares and triangles and circles. Okay, same thing for colors. And the difference is not just that some languages, as is often taught in introductory classes, some languages have more words for colors, some languages have less. It's that the coverage of the color space really varies. So here is color nameability of English. Larger circle correspond to more agreement on what to name this color. And you see that a large part of the space in English is well named. Compared to Lao, it's not just that Lao has fewer categories, it's that lots of big parts of the space are just not readily nameable. If we look at whether there's consistency in which parts, this is for color, but you get similar data for other modalities, which parts are more nameable, which parts are less, the correlations are positive, but they're not huge. And in many cases, they're near zero. So what is nameable in one language, in this case for color, is not necessarily nameable in another. Okay. So that's the reality on the ground. I can give more examples in the interest of time. I'll cut it off there. What are the consequences? So clearly it affects our communication. If you can't agree on what to call a shape or a color, it's harder to talk about it. Does this have cognitive, quote unquote, non-linguistic consequences? Do easier to name things, which vary. What's easier to name is not the same from language to language. Do easier to name things in a given language make for better cognitive chunks? I'm going to argue the answer is yes. So here is a little set of experiments. Here are a set of colors that in English are very nameable, right? Orange, red, blue, brown. These colors, much less nameable. So in a free naming task, about 80 to 85% of people just use these bare words. They could say anything at all. This is about as nameable as you get. For these ones, there's no agreement, right? This is clearly not gray, but it happens to be the modally produced color, but by very few people. Let's see whether it matters. So here's the little category learning experiment. We compose stimuli that look like these, made up of 3 colors. Participants see these stimuli one at a time, and they have to categorize them by dragging them into one bin or another. They get feedback, letting them know if their response is correct, and then they see the next stimulus. The actual categories are, at least when you see the stimuli all together, extremely simple. So category A has a red swatch over here. Category B has a brown one. Now, other people get these stimuli, but the logic, the underlying logic is exactly the same. So this pinkish one and this olive colored one. We control for perceptual discriminability. We have all sorts of perceptual controls. They turn out not to matter because all of these colors are so discriminable from one another. So it's not a, these differences are not any easier or harder to see. And even if they were at this level of discriminability, it turns out not to matter. What matters is nameability. So people induce these categories that it's about redness and brownness much more quickly. These are adults. We have data from kids. It's interesting that it's not until about 5 that kids can even do this kind of task, this sort of simple rule learning task. Story for another day. But as soon as the kids can do this task, they also show this effect, and their performance correlates with their color knowledge. It's a very replicable effect. It replicates if you manipulate nameability within subjects. So even you might think, oh, well, once you understand the logic of this, that it's about this one color is the diagnostic color, that's what matters, then it'll be trivial to learn these other ones. But no, even when you have the 4 categories, all using the same logic, 2 of them using the more nameable colors, 2 of them using less, doesn't matter. You still get a nameability advantage. It's not just a color thing. You can do this for shapes. So here are shapes that in this configuration are relatively nameable. If you just flip them around, they become less nameable. And categories composed of these less nameable shapes are harder to induce. Now, I'm not in this talk going to talk about the effects of language on perception. I'll refer you to this paper, that it's not just that you see these kinds of effects on high-level categorization, explicit reasoning type of tasks. It goes pretty far down. So refer you to this paper. Do easier named things make for better cognitive chunks? Yes. Yes, they do. So let's keep going. So does knowing a category matter? Okay, you learn English, you learn red and brown, you don't learn names for those olive-colored, brownish categories. But once you learn it, does it matter if language is being used online? On one view, the answer is no. So you have a concept of red or dog. It doesn't matter so much how it's triggered, whether it's activated by seeing a dog, hearing a dog bark, or hearing the word dog, right? Sort of the same thing. On another view, on the sort of words as cues view, it does matter. And the reason it matters, as I'll tell you in a minute, is that words are uniquely well suited to activating your conceptual representations in a more categorical way, emphasizing the diagnostic features, the things that help distinguish category members from non-category members. So here's what we're going to do. We're going to test whether it matters how you activate a well-learned familiar concept like dog, guitar, using verbal means, the word guitar, or non-verbal means. In this case, a sound, that everyone, we normally stimulate, everyone can recognize as being a guitar. Okay, now, of course, any guitar, any picture of a guitar, any sound of a guitar has to be specific. You can't just have a picture of a generic guitar. For example, a guitar is either an acoustic guitar or an electric guitar. Similarly, a sound of a guitar is either electric or acoustic, right? You can't just have a guitar. But of course, in language, you can. That's exactly the sort of thing that language excels at. You can have guitar, you can talk about musical instruments, artifacts, right? You can also talk about more specific things like electric guitars, acoustic guitars, but you can abstract in a way that you can't with perception. So here's the task. We're going to compare how people's visual recognition of guitars is affected when they hear the word guitar compared to when they hear guitar sound. Okay, and you can do this for other kinds of categories, different types of dog barks, different types of motorcycles. Now, why might it matter? Again, it matters because these nonverbal cues like dog barks, yes, people know that they are dog barks, but they correspond, they have more specific information. So people know to a surprising extent that, for example, a lower pitched dog bark corresponds to a larger dog. Okay, they have these motivated mappings. Okay, so the form of the cue, the form of the dog bark is motivated by the kind of dog that produced it. Now, words also have this feature. So when you hear a word dog, you can make all sorts of inferences, automatic inferences about who the speaker is, where they might be from, right? Their gender, their age, but, right, so this relationship is motivated, but in general, iconicity aside, this relationship is not. So, just because women on general have a higher pitched voice doesn't mean that you assume they're talking about a smaller dog when they say dog, right? Okay, and it's this that language brings into the picture. Okay, this breaking of the motivation that you normally see in perception. Okay, and so let's see what effect it has. Okay, so the task here, you hear a guitar sound or you hear the word guitar, it's all within subjects. And now if you see a picture of a guitar, any guitar, you're supposed to press the match button. If it's anything else, mismatch button. So here's what happens when people hear, for example, an electric guitar sound followed by an acoustic guitar. Okay, it takes them about 625 milliseconds to recognize that, oh yeah, it's a guitar. If the sound matches, so if they hear an electric guitar sound followed by a picture of an electric guitar, they're faster. What about if they just hear the word guitar? It has less information, but that's precisely it. It has just the right information. It has the information about the category. So hearing guitar activates your knowledge in a way that allows you to more efficiently recognize a guitar. What kind of guitars? The more typical ones. Okay, so these effects, hearing a word leads to an activation of a more typical representation, not a specific typical guitar, right? But think of it as a distributed representation that emphasizes the features that help distinguish guitars from nearby non-guitars, that help distinguish dogs, if you hear dog, from non-dogs. All right, so if language just mapped onto pre-existing concepts, we would expect less cross-linguistic diversity than is actually observed. I know I just gave you one example, we can talk more about it. More importantly, you would not expect language to really matter in these non-linguistic tasks, and I'll give some more of these in a moment. If we construct our concepts in part through language, we would expect more nameable categories to be simpler to induce. As I'll argue, not just because simpler things are more likely to be named, but it's because of nameability. There's a causal arrow there. We'd expect a label advantage in categorization. So we see this. We would also expect that interfering with language would interfere with categorization. What kind of categorization? That's a big thing. In particular, categorization, people should have a harder time in the absence of language or with limited language experience when language is interfered with, in in tasks that require people to extract similarities in the face of salient differences. Okay, and so here is perhaps an extreme example of such a task, relational match to sample. So in this task, people are supposed to learn that these two circles go with these two squares because they're both instances of this very abstract category of sameness. So you're supposed to not care that these are circles and these are squares, these are red things, these are blue things, but that the relationship between them is what matters. Now, this relationship happens to be very easy to name. Oh, it's same and different. And if you tell people that's what it is, this task becomes trivial. But what happens when people might not know that, are not exposed to labels like same and different? So we ran this task on a somewhat unique population of 20 home signers, children, young adolescents, who were living at a boarding school for the deaf in central China. And so it's a mixed group. These individuals were not exposed. They were born to hearing parents. They were not exposed to any standard sign language prior to coming to the school, but some of them have spent more time at the school than, and others were newer arrivals. The older participants here tended to be in the sample, tended to be those who had a later exposure to standard Chinese Sign Language. And this task was rather difficult for them, but particularly for those older kids, but the kids who were exposed to standard language, sign language later. And in particular, if you look at whether they knew the signs for the word same and different, for the concepts of same and different, those who did performed quite a bit better. Those who didn't were near chance. Okay, now this is an effect of lack of exposure to certain things. But even given a lifetime of exposure, language impairments, interfering with language, affects what people can do with these putatively nonverbal tasks. So here is a task that's been done for many decades. So here it's an odd one out task. Given 3 items, you're supposed to choose which one doesn't belong. And there are 3 kinds of trials here. Here, you're supposed to choose based on size, color, real world color. And this is sort of a more holistic, thematic, functional relationship. So the stroller is the odd one out because the reasoning is something like, you can put a jacket in a suitcase, the stroller is the odd one out, okay? It's been noted that certain people with aphasia, those who have relatively good comprehension, but specific difficulties with confrontation naming, despite overall good semantics, they struggle with this task, particularly for these color and size trials. The reasoning here is that for thematic relationships or functional relationships, there are many ways of doing that task. So all roads lead to the solution. Whereas for color and size, you really have to isolate a dimension and abstract away the differences. And for these trials where that's what you have to do, this is just a case study of one individual, LEW, but there are group studies, including one of our own in 2012, that shows that this pattern holds. There's some recent work arguing against it. We'll see. We can examine this question of whether interfering with language, even despite a lifetime of experience learning these labels, has an effect by using verbal interference. Okay, so here's, in this paper, we ran the same task with college undergrads while they had to do one of 2 dual tasks, interference tasks. One task is having to remember a number, which people are asked to rehearse to help them remember. And when they have to rehearse the number while they do these trials, their performance, not accuracy stays about the same, but in reaction time is worse, but specifically for again, these color and size trials. And that shows up whether you test people with pictures or words. Is this, so it sort of mimics the overall pattern. Is this just a dual task effect? So we can use a secondary task matched for difficulty, remembering visuospatial patterns. And this has no selective interference, or actually no interference at all. Okay. So interfering with language, kind of broadly construed, right? So having limited prior experience because of deprivation of some sort, because you're born deaf, you're not exposed to a sign language. But also, which you might expect that provided you had the sufficient early experiences, doesn't matter. Once language has done its job, it doesn't matter whether what you do with it in the moment. But it turns out that it does, right? Both with interference and for certain kinds of categorization tasks under aphasia. So for the rest of the time, I want to talk about a couple other case studies and reflect on why this question, why I think it really matters. Because it's not just about performance on a specific task for me, it's about how we think about human intelligence and what separates human cognition from cognition of other animals. And I think that by overemphasizing individual cognition, core knowledge, our maybe unique theory of mind, perspective taking, these sorts of things that have been argued to be unique to humans, by overemphasizing their importance, we have underemphasized just the extent to which performance on seemingly basic cognitive tasks actually draw on cultural experiences, language among them, but other aspects of culture matter too. And I think by not appropriately acknowledging the role of language, we end up making certain kinds of errors. So I'm going to give two examples of errors that can result. This first one will take up most of the rest of the time, and I'll briefly talk about the second one. So one kind of error that I think can result is when we point to similarities between groups of people on some task, on one aspect of the task, as revealing something universal about human cognition, and failing to acknowledge the differences that the very same data set plainly reveals. I imagine many of you are familiar with this paper and some of the subsequent work that followed from it. So this is an example of I think, this kind of error. Core knowledge of geometry in an Amazonian indigenous group. The authors write, we ask whether the conceptual primitives of geometry are inherent in the human mind, okay, by studying spontaneous geometric knowledge of a group that doesn't, according to the author, doesn't have this sort of cultural support, no formal education, no specialized vocabulary. And if they can do the task, the logic is that it reveals that they have this knowledge as it's part of core human knowledge. What is the task? The task is an odd one out task, where participants see 6 shapes on each trial and have to pick out the one that doesn't belong. And the criterion for not belonging varies from trial to trial. And so these different trials test for different geometric principles, for example, parallel versus non-parallel lines, different kinds of geometric figures, different types of symmetry, closure, and so on. And so the authors tested these individuals, Munduruku, and compared their performance to Americans. These are kids. I think kids are about 6, the 6 to 7 range, and adults. The main takeaway is look at this correlation, core knowledge. Now, of course, there are also quite a few trials on which the success of American adults is at 100%. The success of the Munduruku is all over the place. And while there's not really a difference in performance for the kids, there's a very real difference in performance for the adults. This task is quite a bit more difficult for the adult Munduruku compared to adult Americans. And so I want to propose that rather than these kinds of results telling us something about core geometry, I think they're telling us more about language-aided induction. And the very real strong correlations you're seeing between the groups and that we replicate among other groups actually have to do with, not with geometry, but with basic visual processing, which you'd expect to be similar. So what would you do faced with this task? Which shape doesn't belong? Well, to many people, looking at this display, the answer comes pretty spontaneously, right? Which shape doesn't belong? These are squares, that's not a square, or rectangle, not rectangles. So the idea is that by virtue of these shapes having previously been, being easy to name, the solution suggests itself, right? So it makes it easier to pose that categorical hypothesis. Oh, rectangle versus non-rectangle. Another way of thinking about it is that this high dimensional space, these shapes differ in orientation and area and height, width, in position, right? Can be collapsed to squares and rectangles, or even squares and non-squares. Okay, so you're collapsing it to a lower dimensional manifold. Now, namely, these different trials vary in nameability. So if you ask people what makes this one different from these, English speakers all say it's not a square versus rectangle, and so on. For something like this, people say all sorts of things. Okay, so the first thing we can do is, just for American adults, does naming complexity, in this case measured as the number of modifiers people used in their names, does it predict performance? Yes, it does. Okay, here are the easy to name ones. Here are the more difficult to name ones. Now, of course, the obvious thing is that, well, doesn't this just mean that hard distinctions are also hard to name? Yes, but that's not the whole story. English nameability predicts performance for English speakers, not really for the Munduruku. Okay. Another way of putting it is that the trials in which the Munduruku are most disadvantaged relative to English speakers are the ones that are most nameable for English speakers. Okay, here's that relationship. So high here means that a relative advantage for American adults, and you see that those are the ones that are most nameable. It's not just the Munduruku. We've replicated this in another group, Shawi, who on average perform even worse than the Munduruku. Replicate the nameability. So what's easy for English speakers is not easy for everyone. But in this group, some of the individuals have more education than others, and some know Spanish, which of course, for these purposes, is identical to English in terms of nameability of these shapes. Age did not predict performance, education did not predict performance, but knowledge of Spanish did. Okay. We've also tested the same group of home signers, this time comparing a group of kids to a control group of younger kids. So if anything, they should do worse, who have normal hearing, who are native Mandarin speakers. The hearing children, Chinese hearing children, do basically the same as American adults, and they do better than American kids. here is the group of the sort of quote unquote home signers. Okay, their accuracy is again not predicted by age, but it's predicted by an admittedly rough measure of teacher-assessed language ability. Okay, and again, English nameability predicts performance for English speakers in particular. Now, we're in process of obtaining nameability measures from a few other languages to see, for example, if Shawi nameability predicts performance specifically for Shawi. What about interfering with language? What happens if you do this task while messing with language? Well, this is within subjects. There's a small but reliable decrease in performance. So yeah, it messes people up a bit, but it's not like, you suddenly lose all prior knowledge. What's interesting is that that relationship with nameability is significantly decreased. So verbal interference, in other words, selectively impacts the normally easy things like rectangle versus square. Those suddenly become more difficult. Okay, so the items most impacted by verbal interference are the normally most easiest ones. They're still relatively easy, but not quite so easy. Okay. So what makes them simple, perhaps, right? Things like red things, is that they become simple in part by learning these chunks through learning our language. How am I doing on time? Am I okay?
Yeah, you have about 10 more minutes.
Okay, great.
5 to 10, actually. Sorry.
Awesome. Okay, so let me then get to the final one. This will just take a couple minutes, so I'll have some extra time for questions. Fluid intelligence. So this is not a group of psychometricians, but this is the idea that intelligence can be partialed into what's often called crystallized knowledge, things that we learn, and fluid intelligence, something like reasoning in the absence of any specific content, is an idea that's been around for now going on 100 years. And it, I think, has played an outsized role in how we think about intelligence. For better or worse, the ability to form appropriate categories, as I said, has been for more than a century central to our idea of intelligence. And not coincidentally, this is how we tend to measure it. So we give people puzzles like this. So this is a matrix problem where people see these kinds of forms and have to figure out what sort of pattern they follow such that, and once you figure it out, you can complete this missing cell. Okay. Now, unlike reasoning in verbal problems, performance on problems like this is often argued to not tap any culturally acquired knowledge or linguistic forms. This has had enormous consequences because while you can't, part of IQ tests, for example, big part of IQ tests is vocabulary knowledge. Well, people who are exposed to more books, right, are going to learn more words, right? You have to adapt it to different languages. So clearly, no one claims, right, that you learn words in the absence of experience. But people do claim that you know how to do these problems, and that's if some people are better at it than others, it is because they are better at reasoning. And this has licensed people to do things like interpret differences, group differences in performance on matrix problems. So these kinds of problems are what mostly compose so-called culture-free or culture-reduced intelligence tests. Has given license to interpret differences in performance as differences in intelligence. Right? So there's a lot at stake here. How nonverbal is fluid reasoning? So this is just the first step in addressing this question, some work that will hopefully be coming out soon. we took matrix problems from the standard Ravens matrices, the standardized test, and we computed a nameability measure by asking people to describe, we extracted the elements, we asked people to describe how the highlighted cell, how you would distinguish it from other cells. And so here people say it has 3 vertical lines, for example. And then we compute Simpson's diversity index as a measure of agreement. The idea being that you can then average that together for the problem and obtain a sort of a nameability metric for each problem. And so on this metric, this problem, they have very similar logic, but this problem is relatively more nameable than this problem. Does that predict how well people do? The answer is yes. So for the logically simpler problems, it doesn't really matter. People do well on those regardless. But for problems that involve kind of computing over more rules, nameability matters. Okay, so higher nameability, better performance. We can also manipulate nameability directly by constructing our own matrix problems that now hold the logic exactly constant. So this is the same problem. Obviously, these two problems are not shown to the same person. This is between subjects. But this one is composed of more nameable elements, stars and circles and squares. And this is composed of less nameable elements. We then control for visual complexity, for visual discriminability. And what happens? Controlling for logical complexity, how many rules you need to solve it. Nameability, again, matters. More nameable, better performance. And there's a small but replicable and reliable interaction with visual distinguishability. So when the visual features are harder to distinguish, nameability matters more. Okay, so if these are very simple forms, it's less important how nameable they are. But if these are more complex forms, this squiggle versus that squiggle, right? Or if they're harder to distinguish, rather, now, if they're easier to name, that helps. Okay, so I started with this question: do the words we learn as part of learning language help structure the mind? I've given a few different kinds of evidence in favor of the affirmative, right? That yes, I think they do. I'm not suggesting that language is everything. Clearly, many, perhaps most of the categories we would learn regardless. Or maybe we don't even need to learn many of them, right? We know them regardless. But many others, many of which we take for granted, we might not. And the biggest, I think, takeaway message is that I want to argue that culture really matters. Language is a product of culture, but it's not a product of individual minds. None of us are smart enough to individually reinvent the idea of naming colors, right? Or numbers, or the idea of treating very different looking triangles as actually being the same thing for geometric purposes, as all being triangles, right? We're not smart enough to do that, but we are smart enough to benefit from the already gradually accumulated knowledge and learning it, right, as an individual learner. Thanks.
Thank you, Gary. Take a few seconds to congratulate you or thank you, you would say it. And we'll have some time for questions. We'll take the first question from Asia. I hope I'm saying that right.
Hi. Thank you. Yes, it took a second to unmute. Thank you. This is fascinating and made me think about, just one brief comment, one question. So the comment is that it made me think how artificial or how academic academically useful rather than real life useful our geometric concepts are. To differentiate rectangles from squares helps you really well to do your maths exercise with your kids, but to survive in the jungle, these are probably useless. And you know, coming with our concepts to test the intelligence, overall, it's just such a bizarre idea that, yeah, so yeah. Thank you for bringing this awareness. And when my question deals with nameability of things, so you said that nameability matters more for objects that are visually harder to differentiate between. And it seems that this observation makes a very strong implication about things that we cannot observe in principle. Concepts that deal with emotions or abstract concept like democracy, their nameability probably has an even stronger influence. So I was wondering what your thoughts are on that issue.
I very much agree. So we can observe behaviors, right? We can't observe mental states, but we make inferences about mental states from behaviors. But language is a behavior that can make that inference much simpler, right? So you can observe that someone, you can infer that someone is hungry, right? Through their actions, or they might just tell you, right? I'm hungry. And I think a lot of the development of theory of mind, and there is, you know, lots of work on the link between both emotional categorization, theory of mind, and language. I think a lot of it is due to what you just said, that there's a lot of information that's not directly observable that can be made just much more explicit just by talking about it, by talking about our emotions, talking about our mental states. And that provides training to help us associate ongoing things, right, with what people tend to think about, such that we can, I would hypothesize, we end up being better at doing it even in the absence of people talking about what they're thinking, right? So yes. And by the way, one with regard to, you know, one kind of simple intuition for visual distinguishability and nameability. So think about letters in an alphabet or in the writing system you can read, right? You know, things that are visually very similar, a B and a D is extremely similar, right? It's just a mirror image, right? They become, and we've shown kind of at a low level visually, more discriminable by virtue of learning those categories. Whereas when you look at an unfamiliar writing system, right, you have the same visual system, right? But, right, these things are not, you know, they don't automatically pull apart in the way that the familiar ones do. Yeah.
Thank you so much.
Our next question is from Andrew.
Hi. Am I unmuted here?
Yeah, we can hear you.
You started the talk with Jerry Fodor and kind of pitched your view as in contrast with this idea that you've got this innate conceptual repertoire. And as far as I can see, a lot of the evidence you were showing is indicating that, you know, words, labels facilitate reasoning with certain categories, but I'm just not getting the evidence that it actually gives you a category that you would not have otherwise. It seems like you could explain a lot of this data just by saying, oh yeah, when you have a word there, it draws your attention to a particular part of conceptual space that your attention might not be drawn to otherwise. Or it gives you something to manipulate in working memory, this discrete unit to manipulate in working memory that you wouldn't have otherwise. But that category that it's pointing to could have been there all along. So I want to hear your argument for why this is against it.
Yeah, it could be, but is it, right? So people sometimes, I think, confuse capacity for actuality, right? So when someone like Pinker says, you know, the fact that we can learn other languages is, you know, shows that Worf didn't know what he was talking about, because how could you learn this other system, right? Otherwise, you know, if learning a language somehow constrained your thinking. But this is, you could learn it, but did you already know the categories of this other language in the absence of being exposed to them, right? And so you're right that the mechanisms, there's nothing magical about language or words, right? It works through the same mechanisms, I think, as all other kinds of learning. But so yes, we could learn these. So the Shawi speakers, the Munduruku, could learn circles and triangles, right? Of course they could. But given the task, they're not using this knowledge, right? They're not, using it. So what we have to go on is behavior, right? And given the same task, some people, given this task, recruit these categories, and other people don't. The ones that don't, it could be that they know this stuff, but it just didn't occur to them. But I would say that, that's fine, right? Because if you somehow know it, but that knowledge is so latent that it doesn't come out in these various tasks, right? What is it doing? And I think, for a philosopher, right, it might make sense to hypothesize about latent knowledge. For me as a cognitive scientist, right, I want to see that it's doing stuff. Otherwise, so what, right? So
Thanks.
Yeah.
Next question will be from Matthew, but I just want to say first that we're now spilling over into the general discussion period. So if you have a question that's relevant to Uli's talk as well, feel free to register in the chat.
Okay, well, actually, it sort of is. So this is amazing work. And thank you for the presentation. I'm wondering whether it seems to be that the thought, well, a common thought I heard is, well, yeah, language can affect thought, but perception, forget that, right? Perception is modular, blah, blah, blah. Forget it. Language will not penetrate perception. And it seems like perhaps what you and Levinson and others are showing is that we got it wrong. It's the other way around. When something is perceptual, so, we'd have to argue about what we mean by perceptual. It's a terrible term. But things that have certain characteristics, like they're like you can have adaptability, like adapt to red. You look at red for a long time, it changes what you see afterwards, etc. Right? I think we could. There's various persons who have, proposed some definitions of perception, and it's continuous, right? So the space of shapes, like you pointed out. There's lengths, there's orientations, and so on. It might be that the space of even number is continuous if we take the analog magnitude model, and it also shows all kinds of perceptual stuff. So it might be that actually where language is most important is where we use it to sort of impose structure upon the sort of this continuous perceptual manifold.
Yeah.
And that brings me back, the connection with Uri's talk is, it makes me think of George Miller's paper, the magical number 7. So I think, I'm not sure I understood the paper. I was very surprised with how hard it is to understand when I first tried to read it. Anyway, magical number idea is like totally secondary. But what I think he says is that we don't have memory that's great. Like if I present a bunch of tones to you that differ in volume, there's only a certain number of bits you can hold on to. And perhaps at the end, he proposes this idea of chunks. I find it so close to what you're talking about.
Yeah.
That language allows us to do just that, to do this compression, like to compress a lot of information into a small symbol so that we can remember more. I wonder if Uri, if that's connected at all. Uli, I'm sorry.
Very much so. So
yeah.
let me just quickly touch on the first thing you said about perception. The way you put it is very much how I think of it. It's not that,
cool.
You know, the idea that, perception, language affects perception is very broad. And it's so vague, right, that if you want to argue that it doesn't, you can find tasks in which it doesn't. And if you want to show that it does, you can find tasks in which it does. And then people argue, well, is that really perception? I do, people can read more about it in that TICS paper that recently came out. But the take-home message, I think, for all of these studies is that to the extent that the task requires or benefits, performance benefits from kind of a categorical overlay, as you say, you're going to find linguistic effects. Now, that's true for tasks that operate in continuous spaces like color. Yes, color is a continuous space. Labels are not. Color labels are not. And then a task that requires people to distinguish very subtle differences between colors, you find no effects of language and no categorical perception whatsoever. There is no categorical perception on these tasks. It's gone. But as soon as you have some trials in which it pays to distinguish between greens and blues, right, and blues and purples, now you get categorical perception, and that categorical perception is quite strongly exaggerated if you present people with a label, for example, and interfering with language removes it further. So that's when you start to get these effects. And so, yes, absolutely, a lot of real world perception doesn't require that. It's not categorical. We care about the specifics, not the category. And so in those tasks, you wouldn't expect effects of language online and cross-linguistic differences, apart from the sort of training effect that language provides you. So Asfa may talk about, for example, smell vocabularies and how speakers of some languages and some cultures end up being much better. Yeah, I don't want to dominate the discussion. I'll just say Miller and others of that time period. I think that work is really seminal, and when you read it, it's incredibly rich. So Roger Shepard's and his colleagues' first examination of learnability of different types of categories, they were very actually explicit that it could be that it has a lot to do with language and which ones are easier to express. And over the decades, that kind of got erased because it seemed like hard to quantify, but we can quantify logical complexity. And so let's pretend that language doesn't matter. And because often the subject, the participants are all quite linguistically and culturally homogeneous, for those samples, right, it might not matter much. They don't vary on these dimensions. And so they've all benefited or not benefited to the same extent from these language-derived chunks.
We do have 3 more questions I would love to get to if there's time, but I want to give Uli a chance to speak on this if he has something to say.
Don't really have much to say, but one direction that I've sort of thought about this role that like language might give you some scaffolding to aid your reasoning relates in particular to theory of mind. And then, I mean, there's also in the linguistic literature this idea that the processing of complex sentences itself sort of involves sort of phases, and so you process have to sort of proceed in steps and process a small phrase and then build that into a single unit, and then very specifically embedded sentences would constitute a phase on their own. So I mean, I do think that that's interesting to explore, but I don't have any rich detail to I mean, there are people here probably who know much more about this.
we'll take the next question from Veronique then. Are you able to unmute yourself?
Good, thank you. Yes, so that's a question for Gary, as probably expected. I actually wanted to respond to the presentation you gave of our geometry findings. I'm not contesting any of the effects that you showed, and I'm not even contesting the idea that for US people or perhaps US children as well who have lexical terms to describe the categories that they're actually using them. Actually, in a follow-up to this work, we focused on some categories, and we found that for US children, the right angle, when they have a word to label right angle, they actually pick up the category of right angle, but they don't before that. So we also found effects of nameability. However, what I disagree with is the second part of your conclusion where you say, thus, this is only low-level visual processing. And I think even your data speaks about that, because even in the populations where we don't have names, we do see that performance is above chance. So I think the way I think about this data is that indeed there's a difference between the US adults who have learned about geometry and probably got an extended vocabulary to talk about geometric properties and the Maduraku and the children. So there might be two different factors, one factor that is related to nameability and one factor that is more nonverbal geometric concepts. And my prediction then would be that if you run your analysis controlling for nameability, you should still find a correlation between the performance of the US and other populations.
And we do indeed find that. I have to admit that that correlation, it was larger than I expected, including the correlation with, for example, these home signer individuals. But the question, I guess, is what produces it? Because we would expect, for example, geometry and language aside, for all of them to distinguish between, for example, one object and two objects, right? Or things, that, for example, so it becomes an issue of interpretation. So if they distinguish between, for example, something with a hole in it versus something that without a hole, is it reflecting an abstract geometric principle, topological principle, or is it something like, has a hole, right? And where they relate it to maybe some real world object, right? Like these don't have holes, this has a hole, which I think they would appreciate in the absence of language. But it's this more concrete kind of knowledge, rather than the more abstract generalizable knowledge. And I think I don't have the data to argue strongly for the position that it's concrete knowledge, but I think at least there's the possibility that one does not automatically kind of get the inference that above chance performance on this indicates knowledge of these abstract geometric primitives.
Well, the question is, are the stimuli well controlled enough to permit this inference or not? And I agree, it's so it's only one trial per concept. So one could argue that even indeed they're not well controlled enough. But then going back to that further research where we looked at right angle, we also looked at parallels. And here the controls are easy because you can actually it's much more simpler stimuli. And although we do get effects of nameability and learning the lexicon for right angles, we don't get it for parallels. So,
interesting.
So there seems to be there are some concepts that are there without the names.
Yeah. Thank you. Yeah, That's interesting.
I want to try to squeeze in one more question. We're already cutting into the asynchronous presentation slot. So we'll take one question from Liz, and Wade, Susan, Alexis, anyone else who had a question, please ask it in the Slack afterwards.
Hi, this is a question for Gary. Thank you so much. That was a really interesting talk. I guess I'm curious about the last couple of data sets that you presented and arguing for nameability, controlling for other things like complexity, familiarity, frequency. I'm having trouble imagining things that are equally complex but very different in nameability. So I'm wondering if you could give me some more examples, or maybe especially for the Ravens matrices experiment.
Yeah. I'll just, in the interest of time, I'll post them in the Slack channel. So complexity, visual discriminability, those things are relatively easy to control. Something like familiarity becomes, or meaningfulness, right, becomes very tricky, right? So it depends on how we define it. So it's not the case, right? There are certain things that if you define familiarity as just frequency of exposure, right? Well, there are lots of things that we're very frequently exposed to that we just don't care about. We don't talk about, we don't think about, we don't categorize, right? But the things that we care about, some of those, you know, we also talk about, right? Like some of those are, so for example, in the color domain, most of the colors to which we're exposed are low saturation, hard to name colors. But the colors we care about, the colors we name, the colors that we use in color coding things, right, are very highly saturated. And so if you ask, can you control for color nameability while, can you manipulate color nameability while controlling for familiarity? It becomes really tricky because familiarity defined how, right? You know, cars only come in certain colors. The natural world comes in all sorts of colors, right? And so what kind of experiences do you emphasize in quantifying familiarity? And you can't just ask people to rate how familiar are you, because of course those ratings are going to be strongly influenced by language. And so it's things like meaningfulness and familiarity are, and nameability are quite tricky to disentangle in the end.
Okay, thank you to everyone for stopping by for this session. We'll have the asynchronous presentations now for an hour, and we'll see you back here in the same Zoom room for the second session, which will be on the theme of properties. We'll see you all soon.